Let me give you a little help solving these problems. So in the first problem, we have a light bulb that's being powered by a battery. There is a meter measuring how much current is flowing through our circuit. The first thing it wants us to calculate is the power. We can find the power by simply doing voltage times current. So take the voltage of your battery, put it in here. Read your current meter as carefully as you can. So mine is about 0.88 amps, and plug that in here. Once you get your power, that will be your first answer that you want to write down. Next, to find how much charge goes through the light bulb in the time you are allotted, use the idea that current is a measure of charge per second. So take your current that you measured, take your time. So 6 minutes is about 360 seconds, plus another 38 seconds, and put that in as your time. Solve for Q, and put that in as your second box, where it asks you for the amount of charge that flowed through the circuit. Finally, to find the amount of energy, you take your power, which is joules per second, and again, you multiply by the time in seconds. Okay, so your power that you got from the first part, the time that you were allotted, take your energy in joules and put it in here. Pretty straightforward, just making sure you can use your different formulas and ideas. Okay, in problem number 2, you're going to be given a battery where it has a rating. This one is 2 watt hours. Remember, 2 watt hours means 2 joules per second for a time of 1 hour. You turn that hour into seconds, and you will get the amount of joules on your battery. To find out how much charge is on your battery, you start with the joules, and then you remember that the voltage of the battery tells you how many joules there are for each coulomb. So you put the 9.1 joules on the bottom and 1 coulomb up top. Once you divide, you'll get the amount of charge in coulombs on your battery. That is going to go in as your second answer. The energy went in as your first answer. To figure out how long the battery will last before dying, you want to find the power. So take your voltage of the battery, take the current, and for me, I read this as about 0.75 amps, and figure out how many joules per second are being used by your battery. Then you want to start with the fact that the battery holds a given amount of energy, which you already calculated. Then use your power and put your joules on the bottom, 1 second up top, and that'll tell you how many seconds your battery will last. Convert that into minutes, and that answer should go in at the top. So again, use your rating for the battery to find joules. Use the rating and the voltage to find out how much charge is on the battery. And then based on how quickly your light bulb is using energy, you should be able to figure out how long the energy of your battery will last. The final problem is kind of tricky. We're going to be using an immersion heater, which you can actually buy at Target, which will do things like warm up your coffee. And what we're going to do is we're going to try to figure out the specific heat of the liquid that we are warming up. So when you open up the program, your voltage supply should be turned off. What you want to do is measure your initial temperature. And for me, it's 12.9 degrees Celsius. Then flick the switch. You should read a voltage and a current. Don't leave the power supply on too long. I suggest about 60 seconds or a change of about 50 degrees Celsius. Okay, mine took 28 seconds. So then I write down the final temperature, 64.9 degrees Celsius. I subtract those two and get my change in temperature, which is 52 degrees Celsius. Okay, that's going to be important later on. Next, I take my voltage and my current and I multiply them and get my power. This is a much larger voltage than we've been working with and a much larger current than we've been working with. Mine looks like it's about 6.5. So I get my power. I plug my power into my energy over time equation. I had my power supply on for 28 seconds. So I take the power and the time and I get my change in energy. That change in energy is warming up my fluid. So then I want to use the formula heat equals specific heat times mass times change in temperature. I already have my temperature change is 52. My mass, I want to make sure I put it in kilograms. I'm solving for C, and whatever I had for energy, I put in here. It's going to ask for your power. That should go in the first block. And the specific heat that you just found, that should go in the bottom block. If you get these problems wrong, please don't fret about it. Show me your certificate saying that you got it wrong, and also show me your neat and laid out work, and I will give you full credit for them.